I'm going to do another example when we're trying to find the area between the curve or between two curves. All right, so this is the second problem from this chapter in your book. They've given us two functions. They're labeling g of x as this 3x plus 4, and they're labeling f of x as x squared. However, you notice that from the shaded region that we're looking for between the 2 points that we'll solve for in a little bit, you have to notice that g of x is greater than or equal to f of x, from whatever our a and b are. I guess within a and b, say over this interval. So we can use our theorem above, but instead of taking f of x and subtracting g of x, now we're going to take g of x and subtract f of x because that's what we have. Again, those are these functions. These functions above are just placeholders. You can have h of x, I of x, g of x, whatever you want as far as the letters. The one on top is the one that goes in the spot for f of x, and the one on bottom goes in the spot for g of x, regardless of what your problem is labeling them. All right, so we need to find out where these things cross. So here and here, we need to find those values. So we're solving for a and b by letting g of x equal f of x. So our g of x here is 3x plus 4, and that has to equal x squared. So now we're going to use a little bit of algebra, move everything over to one side, and solve for x. So x squared minus 3x minus 4 equals 0. I'm subtracting the left side, moving them over to the right, and then actually just moving everything over to the left because it's looks nicer for me, I guess. I don't know. All right, and then we have two numbers to multiply to give us -4, but add to give us -3 would be x minus 4, and then x plus 1. This means that x equals 4 is the 1 point on the right there, and then this one is x equals -1. All right, so we're going to solve it over that interval. So our area goes from -1 to 4, and now again, the top function is 3x plus 4, and we're then going to subtract the bottom function, which is x squared. And it's with respect to x, so we'll do d of x. This is, again, we can break this into 3, but we've got 3 individual ones where we're using the power rule. So our area equals integral of 3x is 3/2 x squared. Integral of 4 is just 4x. Integral of -x squared is -x cubed over 3. All that's evaluated from -1 to 4. Okay, so now we're going to evaluate it at 4 first. So 3/2 times 4 squared plus 4 times 4 minus 4 cubed over 3. That is evaluating it at 4. And then we subtract it, evaluated at -1, which would be 3/2 times -1 squared plus 4 times -1 minus -1 quantity cubed over 3. All right, so here we have 16 times 3. which gives us, well, actually we have 16 divided by 2. That's probably easier. So that's 8 times 3 is 24. That's what that bit is. 4 times 4 is 16. And then 4 cubed is 64. And that's this left side there. And then I can leave a parentheses or not, but let's do all the arithmetic stuff first. -1 squared is 1, so that just remains 3/2. And -1 cubed is -1, so that's positive 1/3. Okay, so let's see. Let's get the integers out here. So 24 and 16 is 40, plus we have a negative and a -4, which is positive 4, so that's going to give us 44. The thirds, we have -64 thirds minus a positive 1/3, so it's -65 thirds. And then we have an additional -3/2 to boot. So our common denominator is going to be 6. So let's change everything to 6. So that gives us 264 over 6 minus 130 over 6 minus 9 over 6. So for things like that, if you, instead of doing the multiplication in your head or scratched out, if you want to use a calculator for simple arithmetic, you can do that. All right, and now we have these added and or subtracted. Looks like we get 125 over 6. And 5, 6, 7, 8. So it's not divisible by 3, and we know it's not divisible by 2, so that looks like what we're going to have for our solution.